Welcome, friends, to another new episode of Automation Digest. Today, we'll be talking about DSA, and the problem that I have selected for today is spiral matrix. This has been a question which has been asked in many of the interviews. So, to start with, let's understand the question. It is a medium type of question. We are given a M cross N matrix. We have to return all the elements of the matrix, but in spiral order. We are provided with some test data and some constraints where m is told as the number of rows and n as number of columns, where both m and n will be lesser than 10 and greater than 1, which means the length can never be 0. If m and n are different, it also means that it need not be a square matrix compulsorily. We can have square and rectangle matrices both. The value of the matrix is in between -100 and +100. On the right hand side in the editor, we can see that we will be getting a 2D matrix as input, and we have to form a list of integer for the numbers that we are supposed to return, of course, in spiral order. Now, how do we create that spiral order of any matrix? Let's take this example, which has data ranging from 1 to 12. The dimension of the matrix is row equal to 3 and column equal to 4. How do we do the spiral thing? We start from 0 cross 0 and then move rightward till we reach the end of column in the first row. Once we have reached the boundary, we go downward. Where do we stop? We stop once we reach the end of the rows. Once we have hit the bottom, we again change direction towards left. We again stop when we have reached the beginning of column. Once we do that, we again go upward. This time, we stop just one row after the topmost row. Because the topmost row was already covered, we do not go to that row again. After we have reached the position or the second row, we again change direction to the right. We stop again one column before the last column because the last column was already covered. And this ends the matrix, which means we have covered every element. That's why we stop there. So this is what we have to perform. To write this code, understand few things. First, we are taking 4 directions. 1 from left to right, top to bottom, right to left, and bottom to top. And it continues. These are the only 4 directions which are allowed. Also, once we have traversed through a row or column, we remove it from our consideration next time when we come to follow the same direction. So how do we solve this problem? We have to worry about the direction. We have to worry where our direction changes and how are we getting rid of rows and columns already traversed. These are the 3 things if we can handle, we are good with this program. So let's get our hand dirty. First things first, to understand where we are stopping, to understand the direction, we require the position, which means we require to know what is the beginning and what is the end, so that we know where to stop, which means we require 4 variables, 2 for the rows and 2 for the column. So the first 2, top and bottom, are for the rows. Here we are defining the topmost to be 0 and the bottommost to be the length of matrix -1. The next two variables are for columns, where we are defining the left to be 0 and right to be again matrix of 0 dot length -1. Here, matrix of 0 can be replaced by any other number in between top and bottom. What we are trying to do here is, if we already know the row, let's say the 0th row, how many columns are present? If we know the row to be 1, how many number of columns are present? In any of the case, because it is a 2D matrix, the number of columns remains the same. So we could have taken any row. In this case, we are taking 0 just for simplicity. we require four loops, all mutually exclusive for the directions. Also, there should be one loop to govern when are we ending the execution. We require one while loop, which would be for governing end of execution. There will be four while loops inside this while loop, which would be talking about the directions. The first one would be for left to right. Second one for top to bottom. Third one for right to left. And the fourth one for bottom to top. All right. Now we have to understand the conditions that we have to apply. So how do we define the governance? We will be ending when we have traversed every element. As soon as we traverse the elements in a row or column, the row and column gets deducted from our consideration, which also means we require to either add something to top or subtract something from bottom. Same way, add something to left or subtract something for right to get rid of those rows or columns. Which means as soon as my top becomes greater than bottom, that cannot be a real time scenario. We stop. And the left also cannot go beyond right. So that would be the condition. We have to understand that this condition can arise at any point after any of the four loops. So we have to have a similar condition after every while loop so that we can break whenever this condition is not met. Once we have covered this row, our top is incremented, which means our top now goes here. We again do something in this column, then we do something in the bottom. Once we have traversed the bottom, our bottom also gets decremented and it reaches here, the same point which top was assigned to before. So this pointer is now held by both top and bottom. Once we complete the other direction, which is from left to right, we have to stop. Because as soon as we complete this, our top is now incremented again to this point, which is already covered by bottom earlier. So we cannot consider this top. This is the invalid scenario. In this case, we start the left from this position and right from this position. Once we have traversed through every element in this column, we get rid of this, which means our right pointer is moved to the previous column. Once we traverse through this column, the first column, even our left pointer is incremented by 1. During this, our top and bottom is also moving. So after we have traversed through the first row, our top would have moved from the first row to the second row. After we have traversed through the last row, our bottom would have moved from the last row to the previous row. Once we have traversed till 4, we now move towards 5. Once we reach 5, our top is again incremented. Now it is for the column's turn or top to bottom direction. Now our right should be decremented by 1 further. But when this happens, it reaches a point which is lesser than the present left, and it also reaches a point which was already traversed in our previous loop. So in both the example, we come to a conclusion that as soon as our left becomes more than right, or as soon as the top becomes more than bottom, that becomes an invalid situation. So if I can put down the same thing in my code, and this same piece of code can be repeated 2 more times. Why are we not writing it at the end of the last while loop? Because after this while loop ends, we go back to our outside while loop to anyway validate the same condition. This condition can also be written as, we would now need to understand on the direction. During we traverse in the direction, we require two variables to actually go inside the matrix and fetch the value. Once our I and j are assigned to 0, when we are traveling from left to right, our rows remain constant. Next thing that I need to also verify is my j should be less than equal to right. Once I have done that, I would require to assign values. Once I have done that, I have to assign values to a list, which we would be returning at the end. And I have to increment j. Also remember, we were talking about removing the top layer from our consideration after the while loop ends. So as soon as our while loop ends, we have to add 1 to our top so that 0th row is not considered again. Because my top is now incremented by 1, my I should also get incremented by 1. Now, the next part that you would have observed, we have incremented j even after reaching right, which means our j has moved beyond this point. This was our right. J came to this point. After traversing through all the elements, it checked if it was equal to right. Yes, it was equal to right. So it fetched this value as well. Once it was able to fetch this value, the j was incremented, which means it was outside the box now, which also means we have to bring j back to the box. So we are subtracting j by 1. Now the similar condition has to be written 3 times, but for different directions. And our I should be less than equal to bottom. We have to add the value to the result and increment our I. Once we have completed this loop, our right has to be subtracted by 1. Once we have subtracted right by 1, we have to subtract j by 1 as well. And because we have done an extra addition to I, we have to subtract. And because now our I has moved from bottom to outside the box, we have to bring it back to the bottom, which means we have to subtract I as well. Same thing for the third loop. We will now keep our I constant at bottom and we will move j from right to left, which means j should be now greater than equal to the left. Inside this, we have to add to the result. Post this, we have to subtract j because it is traversing from right to left. Once we have completed this loop, the next thing that we should think of is we have already covered the bottom row, which means we have to get rid of it. Because we are subtracting bottom or moving it upwards, we also have to subtract I. Also, if you remember, we are subtracting j after we reach the left. So we have to add 1 to j. Now, the last loop, bottom to top. Again, when we are moving from bottom to top, our column remains constant at left. So j remains left. And our I should be greater than equal to top because it is going upward. We have to add value to our result. We have to subtract I till it reaches the top. Our I is in this position. So this has to get subtracted to reach the top. Outside the loop, we have to follow the same process of removing the column. So here our left has to be incremented by 1. Because we are incrementing left, our j also has to be incremented by 1. Also, because I would have traveled one step above the top, we have to bring it back to the box by adding 1 to I. That's it. Now we just have to return the result. We are done with the code. If I execute this code, both the test case passes. And if I submit my code for test, if you see, it took 0 milliseconds to execute the code, which beats 100% of people. And also it took just 40.3 MB, which beats 98.8% people. And these are all for the worst case scenario. All right, that's it for today. I'll come back soon with some new information in the next episode. Till then, happy coding. Do not forget to like, subscribe, and share.